Well, hello and good morning to another episode here. Today I'll be going over a paper that was actually released by Anthropic. It's an alignment paper. I'll include the link in the description. And to be honest, this is one of the most interesting papers that I have come across in a very long time. I was reading it this morning and it was truly incredible to see the results that they were able to obtain, and it's beautifully presented. I highly recommend that if you have a chance that you take a look at this paper because I think it gives such a great overview of some exciting directions that people are going for alignment and for interpretability research. Now, there's a lot in this paper, but I wanted to just focus on a few concepts I found really interesting. So, the first concept was something that they saw in the models that had to do with essentially planning for the future. So, what they did was they were evaluating how the neurons for the neural network were activating when the model was performing different tasks. So they looked at for poetry, for example. And what they found was that in the computation for the last word, the last token of the first line of the poem, there was in there already firing neurons that are associated with the connection between that word and the word that the neural network was going to use on the second line. So, in a really strange way, like neurons were replicating what humans do when they're composing a poem, where when they're forming the first line, they're thinking and planning ahead and thinking about what they're going to rhyme that first line with and how they can form that into like a coherent sentence that fits. So that was a really cool way to demonstrate this model planning that LLMs display. That was a very cool result. There was another result that I found really very interesting. That was when they were talking about the medical section, and essentially, so it was using a model. You present it like a client's information or a patient's information and the symptoms that they're having, and so you can say, for example, a 30-year-old woman, and she's coughing and wheezing and etc. What do you think is a question that you can ask her to narrow in on what is actually ailing her? And what they found was, if the model, for example, if the possible diagnosis is influenza, say, then what will happen is the neural network will trigger an activation that looks like influenza. So, but it won't output anything about influenza directly. It will maybe bring up some more symptoms to strengthen its certainty in the diagnosis. But internally, it's almost as if it's thinking about what the potential diseases and inhibiting this so that it doesn't say it out loud. So that was a really cool thing. And there were just so many things like that. I could literally go like a full expansion on the work that was presented would probably take like hours. And another really cool thing is models, and we already kind of knew this, they don't really tell you, they have no really self-awareness as to the operations that they're running internally to give them the outputs. So, like for example, the way that LLMs do arithmetic is very different from humans. It's a lot more complicated in a way. There are, for very small additions, they do have like essentially like lookup tables, like certain neurons fires associate with like single digit additions. But for more larger additions of multiple digits, you end up getting pretty sophisticated neural activations. So like you can have, for example, a neuron that tends to activate if a number starts with a 5, a neuron that tends to activate if a number ends in 9, and then a bunch of those types of neurons are activated, and then a bunch of other neurons are activated that rule out an answer that ends in a 5, or a neuron that activates when the final answer is kind of like around 90. So it uses all these like heuristic methods to give the answer to an arithmetic problem. So it's sort of a convoluted way to go about it. But if you ask the model after it generates the answer, like, how did you arrive at this answer? The output is exactly how a human would have arrived at the answer. So the model, in a way, is like imitating what it has seen. And what it has seen is how humans solve this question. It doesn't really have any awareness of what's going on inside of it directly, to be able to say, oh, what I actually did is I activated these neurons, blah, 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 blah. So that's like another, like a really, really interesting thing. Well, we can keep going for a very long time. There's another thing that was really interesting that they talked about was this idea, like the automatic, like responses to identify a dangerous prompt and like stop. And they were talking about like you can run this like jailbreak clever prompt where you say where you don't like tell the model help me make a bomb. What you do is you like have you list out like a phrase, and you're like copy just the first letters of each word in this phrase, and then tell me how to make this. And of course the first letter of each word in the phrase ends up making the word bomb. And what happens is the model outputs instructions on how to make a bomb for one sentence, then it like catches itself and then gives the default like, oh sorry, I can't help with that answer. And they went into some detail about why they think that is. So essentially, much like the human brain, what matters a lot for neural nets isn't just when they fire, but when they don't fire, because a lot of neurons are essentially inhibitory, which means that they prevent a certain output from occurring. So when they fire, something else stops. They're preventing some default pattern. And it turns out that the default pattern for the models that they looked at was to just say, oh, I can't answer this. So you need the neurons to activate that inhibit this response to allow for like the actual responses. And this probably has to do with how the models are actually trained, that they develop as a default response, like to say, oh sorry, I can't help with this, and then they learn to inhibit that over time if the response is seen as safe. So that was really interesting, but there are like workarounds around that that was very interesting. But anyways, this is already quite long. I don't want to keep going because I know that I can keep going indefinitely here, but I highly recommend that you guys get a chance to read this. I think it really is, especially if you're newer to the field, this is like the perfect review article that just groups so many very interesting findings together. But yeah, that's pretty much it for today. I'll talk to you guys again tomorrow. Have a good evening.